Hello everybody and welcome to this next section, which is the system hacking section. Now, before we actually start hacking ourselves, let's familiarize ourselves with the Metasploit Framework so that when I, for example, use certain terms, we'll understand them to mean the same thing. Now, Metasploit Framework, it is basically a tool and it comes pre-installed in Kali Linux. It is used for exploitation most of the time. Sometimes you can use it for scanning. Now, there are some of the modules and payloads and ops and all the other stuff that we will talk about that come already with the Metasploit Framework. But before we begin actually using them, let's try to actually make them understandable, and after that we will execute our first exploit. So, as I said, the Metasploit Framework, tool for developing and executing code against a remote target machine. Basically, for the Metasploit, you actually have the MSF payload creator, which is the MSF Venom. We have the Metasploit Framework, which is the tool that we will use. You can start it up with a simple command called MSFconsole, but don't do it yet, since we have to start something else first. And there is also something called Armitage, which is basically a graphical user interface for Metasploit Framework. Now, the main two things that you will hear most of the time while we are in this section are exploits and payload. Now, I already believe that most of you know what those two are, but just in case, the exploit is the main actually type of the attack. For example, if we have on a target a vulnerable software running, we can take advantage of it and exploit it and run our reverse shell or rootkits on it, for example. Now, I will explain what reverse shells and rootkits are, but basically the exploitation process, there is something that you should know, a term, it's called a 0 day. Now, a 0 day for the exploitation is basically an exploit for a vulnerable system that hasn't been discovered previously. That's why it's called 0 days. It hasn't been fixed yet. It's still vulnerable. There are still vulnerable softwares out there. Now, those are types of the attacks that you will not encounter, most likely, since discovering 0 days only happens a few times during a year. There are different types of 0 days. Some can be more dangerous than others, but the most recent one that I have heard of was the 0 day in 2017, an exploit that basically allowed anyone to access a Windows 7 machine, and I think also a Windows 8 machine, without a user clicking on anything. So you could just connect to the same network and basically exploit the Windows 7 machine if it is running a 445 open port or SMB open port. It was discovered by some hackers, I believe, it was an NSA exploit called the Eternal Blue. I will also show it to you in the Metasploit Framework later on. But that is the basic meaning behind the 0 day attack. Now, we will not be discovering 0 days attacks because most of those attacks, if even discovered, can be costly can cost from above $100,000. So if you were to, for example, discover a 0 day, you can sell it for $100,000 and more. I believe for the iPhone, if you were to find for the iPhone a 0 day, you would get paid by Apple $1 million. But I only heard that, I'm not really sure if that's true. But we won't be really getting ourselves with that, since we will be exploiting targets with already known exploits and with our basically reverse shells that we will run on the target. So there is something called payload, which is basically the reverse shell. So that is something that after we exploit the vulnerable software, we deliver its payload. Now, we can deliver to machine. We can deliver it to machine in order for it to give us access or some information back. Now, we will cover all of them in detail in the next lectures. But for now on, let us actually start up the Metasploit Framework and see its environment. Now, I would advise you, before you actually type the MSFconsole, which is the command for starting up the Metasploit Framework, let's run the service PostgreSQL start. So service PostgreSQL start. This will make your Metasploit run faster since it is using the database. Now, you do not need to do this if you don't want to, but as I said, it will only make your Metasploit run faster. So Now that we ran this, we can finally open our Metasploit framework. In order to do that, you just need to type here MSF Console, click enter, and wait for this to open. Now, since this is a virtual machine, this might take a few seconds to open depending on your PC speed. And once it does, we will actually cover some of the basic commands that you will use in order to navigate into the Metasploit framework. So let us wait for this to open first of all. So here it is. The first thing you notice is this banner right here. I believe it is every time different or something like that. The next thing you see is the available things on the Metasploit framework currently at this time, which is the 3rd or 11th of March 2019. We have 1,854 available exploits. We have 1,049 auxiliary modules, post-exploitation modules 325, 546 payloads, 44 encoders, 10 knobs, 2 evasion. Now we will cover what all of these are in the next lecture, but for now on, let us actually see how we can navigate through this framework. Now, as we can see, our command line is right here, MSF5 and then this arrow, and here we type our commands. So the first logical thing that we should do is type help. Now, help will give us the available commands that we can run right now. So we can see some of the useful ones would be use command. You will use it a lot. It's basically you just type here use and then the name of the actual exploit that you want to use. So here it is. Selects a module by name. But in order for you to select a module, you need to know its name. So since we are beginners, we do not know the name of any module. So we can also use the search command in order to find out the modules. Search modules names and descriptions. If you just type here search. And let's say we want to find Windows exploit. So just type here search Windows. It will give you all of the available Windows exploits on this Metasploit framework. So let me just zoom out a little bit so we have a better look at this. So these are all of the available modules available for the Windows exploits. As we can see, for example, exploit Windows is AP, W3 who query, and you can also select that and see more details about it. Now, there are lots of them. As I said, there are over 1,800 exploits in the Metasploit framework. We will cover only a little of them, since if we were to cover all of them, we would make this course 1,000 hours long. Now, let's say we want to use, for example, I don't know, let's select random, some random exploit. Let's say, this is auxiliary, let's take this one. So, example, exploit multi-browser Java Reno. You can select it. You can also see the date that it came out, so 2011, and its performance says excellent. Now, Java Applet Retro Script Engine Remote Code Execution. So, in order to pick that exploit, we will simply just to type here use and then paste the name of the exploit itself and just press here enter. And you will see that you type the correct name for the exploit once there is red letters in this bracket, so it means this exploit exists. Now this selected exploit, we can see its options with the show command. So show options will give us all of the options for this exploit and what it requires in order to run. So we can see module options, exploit multi-browser Java Reno, and then we can see server host 0.0.0. This is a required field, so you need to specify this if it is not specified. Description for that field, the local host to listen on. This must be an address on the local machine or 0.0.0.0. Now, server port is 8080, current setting. It is also a required field, the local port to listen on. And other things such as SSL certificate and URI path are not required. As we can see, they're all under no. You do not need to specify them in order to run this attack. Now, down here we have the exploit target. So in order to check out your available targets, you can just type here show targets. And it will print out a list of all of the targets available for this exploit. So we can see this exploit we can run generic Java payload, Windows Universal, Apple OS X, and Linux x86. So basically it can run on any platform. Now, in order to, for example, if you didn't know much about this exploit, you would want to find out more about it. You can do that with show info option. So this will print out what exactly is this exploit. So you just type here show info. Let's scroll up to the beginning. It will say name, module, platform. It will basically give us the output of this command before. So available targets, check supported, no. It doesn't have an auxiliary module that it will check if this exploit exists. Basic options are also something that we saw with the previous commands. Payload information and description. Now description is most likely something that you will search with this command. So this module exploits a vulnerability in the Reno script engine that can be used by Java applet to run arbitrary Java code outside of the sandbox. The vulnerability affects version 7 and version 6, update 27 and earlier, and should work on any browser that supports Java, for example Firefox, Google Chrome, and so on. You can see some of the other references right here. So if you were to copy this link, let's copy the first link. Let's see, open link. I'm not really sure if it works like that. So open link, it's ready, and it will lead you to a page where you can, for example, read more about this payload. Pardon me, about this exploit. So as soon as this loads, you will be able to, I believe it is a Rapid7 website, not really sure where it is taking us, but it should take us to a page where this exploit is in greater details. So vulnerability type, we can see that its score is 10.0, so this is a very serious exploit right here. And basically, let's not just bother ourselves with all of these options right here. You can read it if you want to. You can also try to visit other sites as well that also explain this exploit in greater detail, but we will not be doing that at the moment. Now, if you want to deliver, for example, a payload with this exploit, you would see your available payloads with show payload options. Show payloads, I believe it's spelled like that. So show payloads will give you your available payloads for this exploit. So for example, you cannot use a reverse TCP Windows exploit payload in here, since it is not specified in show payloads options. You can only use all of these other options available, or payloads available. In order, once you check out all of these payloads and once you choose one, in order to set it, you will have to type here set and then payload and then space, and then you basically just copy any payload you want. So let's copy this one or the payload that you chose, and you set that payload. As we can see, we successfully set the payload with this command. If you were to mistype it, it would say no such payload available. Now after you select payload, you want to type show options once again, and you will see that we also have some of the additional options for our payload. Now most of the time you will see these two options. One of them is lhost and one of them is lport. Now the lhost is basically, as it says right here, the listen address, so it is basically your Kali Linux machine, since you are listening for the connection back from the target machine. The lport is the listening port on which you are listening, which is most likely by default on Metasploit it is 4444. So in order to run this, you would set lhost 192.168, or let me just first check out my IP address, which is .1.7, and you would set lhost 192.168.1.7. Show options. And now we can see everything is set, and now you would be able to run this payload or exploit against your target if you find a vulnerable one. Now I will not be running this exploit since I don't really have a vulnerable target, but I just wanted to show you some of the commands that you will use in order to select your exploits. And we will actually exploit and run some scanners in the next sections, right after we actually cover the basic structure of the Metasploit framework itself. I will explain what NOPs, encoders, payloads, exploits, post-exploitation tools are in the next video. But before I finish this one, you might have noticed that I actually type here ifconfig, or let me just type it once again since I forgot G, if it were to give me my command toolback, so ifconfig, and it actually outputted me my ifconfig command. So you notice that you can actually run the system commands from this command tool. So you can run all of the commands that you can run from a simple terminal in the Metasploit Framework command line. So you can also run nmap or netstat -nr. You can also run anything from this command tool as well. So you do not need to close Metasploit while performing the attack or any other scan that you want to perform. So that would be about it for this introductory video. Now you might still be wondering about some of the things. Don't worry, we will also cover them in greater detail in future videos. Right now I just wanted to show you the simple environment of the Metasploit framework itself and some of the more important commands that you will be using. So I will explain the modules that we have in Metasploit framework in the next lecture, and I hope you're there. Bye! Hello everybody and welcome back to the next lecture in the Metasploit framework or system hacking section. So let us actually take a better look actually at the structure of the Metasploit framework itself. So in order to do that, let us first exit the command tool. Let me clear the screen. And the first thing you want to know is where are all the modules, encoders, payloads, exploits actually stored. So they are stored in the user. Let me just cd user share, and then you go to the Metasploit framework. Once you change directory to that, you can just type here ls and you will see a bunch of these files, and I will show you what are the more important ones and the ones that we will use. Now let's see first of all. So the first one is the Msf Console. Let me just find it, which is right here. We used it in the previous video. It is used as a program to run the console itself and actually perform the attacks. Now, one of the also important ones is the MSF Venom. Now, this program we will use in order to create our payloads, our interpreter shells and backdoors. So we do that with this command like right here, and also you can update your Metasploit framework with the msf update command. Most of the others are not so important at the moment. Now if you want, it's good to know that the Metasploit framework and all of the exploits are written in Ruby, which is a programming language similar to Python. So if you know that language, it is also a plus. Now in order for you to find all of the exploits and payloads, you need to go to the modules directory. Everything is stored in there. So if we go into the modules and click ls right here, you will see that we have all of the things that I talked about before. So we have auxiliary, encoders, evasion, exploits, NOPs, payloads, posts. Now let's explain all of those in detail. So exploits, as we said before, they're basically used to target a vulnerable software running on a remote machine. So let's actually change our directory to exploits and cd exploits and type here ls. You will notice that you have a different exploits for different types of operating systems and different types of platforms. So for example, you have Linux, Windows, Unix, Solaris, Android, Apple exploits, so also browser exploits, as we see Firefox. There are a bunch of these separated directories for different types of exploits. So let's actually try to find the exploit that I talked about in the previous video, the one for the Windows 7 and Windows 8 machine, I believe, which is the Eternal Blue exploit from 2017. It is a Windows exploit, so we go to the Windows and we type here ls. There is a future division between all of these exploits, as we can see right here. Some of them are mostly divided by the port number or the service that they are running on a certain port. For example, we can see HTTP, it is running on port 80. We can see SSH port 22, FTP port 21. We can see SMB port 445, I believe, or something like that. So let us go to the SMB, since there is the Eternal Blue exploit, if you type here ls, you will see a bunch of these different exploits used for the SMB. Now, here it is, the Eternal Blue Windows 8.py exploit. We also have the regular Eternal Blue exploit, and all of these are .rp, which basically stands that they are Ruby files and the Ruby exploits, or exploits just written in Ruby, as I said before. So if you wanted to, you could actually nano some of them in order to see how they look like. So MS17, let's see how does Eternal Blue look like. So .rb, and we can see the code of the exploit itself. So it is written in Ruby, as I said. You can check out a bunch of these things right here. Now, I do not know Ruby, so I will not be actually explaining what all of this does. It is similar to Python. You can actually understand it if you did learn some of the programming languages before. But for now on, I just wanted to show you the simple code behind this exploit. So let's close this. And let's actually go back to the modules. So we change our directory back to the modules, and let's talk about, for example, the payload section. So for the payloads directory, let's change first of all the directory to payloads and type here ls in order to see what we have. And here we have different types of payloads. As I said before, those are files that we send to victim, for example backdoors. Now, as we can see, there are three types right here, singles, stagers, and stages. Now, singles are basically used to, they are smaller payloads, and they're used to actually perform only one action. Stagers right here, they can be used to deliver another payloads, and the stages are some of the larger exploits, or not exploits, some of the larger payloads, pardon me. For example, the interpreter shell that we will use in most of our attacks. Now, what is an interpreter shell? That is basically a shell with a bunch of different options that we can use after we exploit the remote system. So we can actually screenshot the desktop, we can run a keylogger, we can bypass antiviruses, we can do a bunch of these stuffs with the Meterpreter reverse shell. So it gives us a bunch of options to use. We can upload other payloads as well with Meterpreter, we can download files, upload files, and some of the other things that we will cover in the next tutorials. So that would be about it for the payload. Let us check what else we have. So we have auxiliary, so let's go to the auxiliary modules and just type here ls. And you will see that they are divided also in different types. So we have fuzzers, spoofers, sniffers, different type of auxiliary modules. But most likely auxiliary will only be scanners that you perform on a target. So for example, you can scan if a target is vulnerable to some type of the attack. And sometimes auxiliary modules are also used to brute force, for example SSH, Tomcat, and other different stuff that we will also cover in the next video. So that will be about it for the auxiliary. You can check out all of these other subdirectories if you want to and see what does it have in them. For example, let's go to fuzzers. You will have in the SSH also some of the some of the auxiliary modules written in Ruby language. So that will be about it for the auxiliary. Now let's talk about the encoders. So if I type here ls, you will have the encoders. Let's go to that directory, type here ls once again, and these are the encoders for different types of machines. So encoders are mostly used to bypass antiviruses. Now you can change how the code looks with the encoder, or you can scramble the code and then the antivirus database can't recognize it actually. Now how the antivirus databases work, or basically how does most of the antivirus work, is they have a huge database where they have all of the known exploits, all of the known viruses, trojans, and malware basically that they have in their database. And once you run some of the program on your PC, which is a malware, and it is also known to that database, your antivirus will prevent it from running and it will delete it. But if you, for example, change the code a little bit and scramble the code, or even better, write the malware yourself, then most likely most of the antiviruses won't be able to detect it, since it is firstly time that they see a code like that, and that code is not in their database, so therefore they cannot really detect that code. And they let it as a normal program and not as a malware. That's why coding your own malware is a big advantage. So that would be about it for the encoders. We will also show how to use them later on, but for now on let's just explain all of this. So the post right here is basically some of the tools or programs that you will use after you exploit the target. For example, you send Meterpreter, which is a reverse shell that we will use. You can upload from the Meterpreter other post-exploitation programs that you can use to gather, for example, passwords gathering, or basically any other information gathering you want. You can gather, for example, cookies if you want to from the certain browser. The thing that you might not really know what it is, which is NOPs, well, basically, if you ever encountered in assembly code, or if you're an assembly programmer as well, you will most likely know what NOP is. It is short for no operation. It is basically a command in the assembly language that just performs no operation. Now this is most popular known for on x86 chips as 0x90 bytes. So this is the byte for a NOP instruction. When a processor loads this instruction, it simply doesn't do anything. It basically just skips those instructions until it comes to the next useful instruction. It just does nothing for one cycle and then advances the register to the next instruction. Now, why are these NOPs useful? Well, basically, the NOPs keep the payload size consistent. The practical importance of this has to do with writing instruction jumps. Now, if you do not know what instruction jumps, it doesn't really matter that much, but jumps can either be relative or absolute jumps. For basically, if you move data around at all with an absolute jump, you must recode any references to it. If you move one instruction around relative to another, you must also recode the relative jump. Putting NOPs basically simplifies the problem, because a jump that lands anywhere in a series of NOPs will continue on the first executable instruction and prevent the processor from reading an invalid code that could stop execution and crash the software. So basically, from all of this, you just need to remember that NOPs is an instruction which is referred to as a byte 0 or as a byte 90, and basically it doesn't do anything. So that's what you need to know. We will probably use it later on in some other section, but for now on this would be enough for you to understand the basic structure of the Metasploit framework, and in the next lectures we will actually start covering some of these scanners and exploits that we can use on our vulnerable targets. So that would be it for this tutorial, and I hope I see you in the next one. Bye! Hello everybody and welcome back. Now, right now what we want to do is basically just start with some of the auxiliary modules that are in Metasploit framework. So we want to basically scan the machine with Msf Console. Now let us first of all start the Msf Console. Now if you didn't start the PostgreSQL before this started, so this can run faster. But while this is starting, I also want to start my OWASP virtual machine. Now if you installed the Metasploitable before, whether it is Metasploitable 1 or Metasploitable 2, you can also run that one as well. Now, as I said before, I cannot get Metasploitable to run for some reason, so I'm using OWASP. I will show you some of the attacks you can perform on Metasploitable as well. So those of you who are opening that machine right now can also do something, but some of the attacks are also similar for the OWASP and for the Metasploitable. So just start any of those two machines. Now I will make sure to mention when the attack is directed to the Metasploitable and when the attack is directed to the OWASP virtual machine. So we wait for this to open. This shouldn't take too long, as we remember this is a small virtual machine. It will prompt us with entering username and password, which is, I believe, username is root and the password is OWASPBWA. let me just see if this has opened. Okay, so this has opened. We get the standard standard command line tool, and we also get this banner right here. So let us first log in into the OWASP. Hopefully it will prompt us with username and password soon enough. Here it is. So the username is root and the password is OWASP-BWA. So OWASP-BWA. And now we are good to go. Let us just first check the IP address of this so we know it. So the IP address of OWASP virtual machine is 192.168.1.2. Good. Now, as I said before, you can run a bunch of different commands, or basically all the commands that you run from a regular terminal, you can also run from the Metasploit Framework command line. So what we want to do is, let's first clear the screen. And what we want to do, let's first take a good scan at the OWASP virtual machine. Now we covered nmap before, so what we want to do right now is nmap -sv, so we can get the version from the services running on certain ports, and then we specify the IP address of our OWASP virtual machine, or in your case, if you're using Metasploitable, of your Metasploitable machine. So execute this, and now we wait for this to finish. It should prompt us with all of the open ports, it should prompt us with the services running on the open ports, and it should prompt us with the version of those services running, which can be useful especially when you use Metasploit Framework. So what we will do is we will try some of the certain attacks on this. Now we can see that the scan has finished it in 18.30 seconds, so we get the open ports, and let's start off with the SSH port. Now we have a bunch of these other ports, such as 139 and 445 running Samba SMBD version 324, which is also a vulnerable software. You also have it on Metasploitable, I believe, the same version. I will show you how you can exploit it later on. But for now on, let us start off by trying to get in over the SSH. So we can see that the service running is SSH on port 22, and the version is OpenSSH 5.3p1 Debian 3 Ubuntu 4. So what we will do is we will use the auxiliary module that is in Metasploit Framework, and we will try it to brute force the SSH on port 22 from our OWASP virtual machine. Or if you're running Metasploitable, once again from your Metasploitable, the process is the same. So let us try with searching SSH. Now this will print us all of the available exploits, auxiliary modules, post-exploit modules for the SSH. Now let us scroll a little bit up, since we do not want post and we do not want exploit. We want some of these modules right here. So auxiliary DOS, we have the auxiliary DOS Windows SSH sys, or basically some kex exchange, not really sure what that is. It says multi-server key exchange denial of service, okay. But this is on Windows, so we do not really need it. What we are searching for is a scanner, and the scanner has to be the login. So here it is, the auxiliary scanner SSH login. Now it doesn't have the date when it came out. The rank is ranked as normal, and it says the SSH login check scanner, which basically means the SSH brute forcer. Now you can also, for example, check the SSH version before you start that. So auxiliary scanner SSH version scanner. So let's first of all start with that one. I believe it will give us the same thing that the nmap gave us, which is the version of the SSH. Now you can use this instead of nmap, since sometimes nmap won't give you the version, and I believe this one is actually more detailed. So as we saw in the previous videos, in order to pick any of these, you just type use and then the name of the module itself, so auxiliary scanner SSH and then /SSH_version, and what we want to do is show our available options. So we can see that we have 4 different options, and they are all required. Most of them are already selected for us, so the R port, for example, is selected as 22, which is good. SSH is most likely always, and also by default, is running on port 22. If it is not, you would want to change this. Threads is the number of threads basically running during this process. Now the more threads, the more faster this process will go. So depending on your power of your virtual machine, you can select, for example, let's select set threads 3. Now we also covered the set command, so you set basically all of these options with just set command and then the name of the option you want and then the number. So we want 3 threads. So if you were to, for example, type show options right now, you would see that the threads are now selected to 3. The only thing that we need to select right now is the rhosts. So the rhosts is basically the target address for our OS virtual machine. It is basically an IP address of your target. So set rhosts. We know it is 192.168.1.2. Oops, .1.2. And now if we show our options again in order to check if everything is good, we will be able to run this. Now if you just run this, so just type here run, this will probably, here it is, this will print out the SSH version that it is running on the target software or on target port 22. As we can see, SSH version, this one, and it gives some bunch of other options as well that could be potentially useful to you. Now this is a simple scan that we did for the first one, but now let's actually try to brute force this SSH on port 22. So let us go to our available auxiliary modules, and what we want to use is the SSH login one. So just select the auxiliary SSH scanner, then SSH underscore login, copy it. Let's go down here and let's do the use and then our module. So copy paste it, and we can see that it changed the module. So let's clear the screen so we can see stuff a little bit better, and let's show our options. Now you can see, unlike the last one, this one has a lot of different modules, or not modules, a lot of different options that we need to specify. Now some of them are required and some of them are not. For example, blank passwords are not required. Brute force speed is required, and we will actually select that to be 5. There's no need to actually make that more. I mean, this we will first of all use a simple password list, so we will not need a higher speed for this. The next things we need, these are all not required. Password, a specific password to authenticate with, no. Well, basically you would use this if you already knew the password, so I don't see the point of this option right here. What we do want is the rhosts, same in the previous scan, so just type here set rhosts and then the IP address of our target machine, so 192.168.1.2, I believe. Let me just check it once again. Yeah, it is .2. And also what you would want to set is basically, let's set again threads to be 3. So set threads 3, our port is correct and it is 22, stop on success, false, stop guessing when a credential works for a host. So you want to set this to true, since there is no really point in continuing the brute force unless you want multiple accounts after you find a host that actually works, so credentials that are useful. So we type here set stop on success, so you can just press tab in order for it to fill the rest of the name, and you can set this from false to true, and we can see that stop on success is now set to true. Verbose you also want to set to true, so you can see all of the attempts that they are running. Now you do not need to, basically, if you want, I always set it to true so I can see the attempts of brute force that we covered already. So just set verbose, again you can press tab to finish, and then true. And now if I type show options once again, we should have all of our options set and ready to go. Now I believe there is something else we need to use, which is the, yeah, of course, we are not set to go. We need to use a password list, since this doesn't have a password list pre-specified, I believe. So what we want to use is basically, let us try to find a simple password list. So let's open up a second terminal. So new window. And we know that there are some passwords in the user share word lists. Now let me view this or zoom this in. If I type here ls, you can see a bunch of these. Of course, we won't use the rocku.txt, that would take forever. These large passwords are most likely the best choice for the Wi-Fi cracking. For the brute forcing, it's really not that good of a choice, since it's not as fast as the Wi-Fi cracking, it's not as nearly as fast. So what we want to do is go to the Metasploit, type here ls, and we will see some of the password lists that are in Metasploit. So we can choose basically any we want, so we do not need to really crack the SSH, we just need to show you the process of cracking it, and we will choose any password list we want. So let's say we choose, for example, this one, mirai user.pass.txt. Now what that means, I believe, is that it also has both user and password. Yeah, it has both user and password separated with the space. So we will use that, and we will see the available option for that right here, which would be the user pass file. So file containing users and passwords separated by space, 1 pair per line, which is exactly what we selected. So we need to set this option right here. So let us set that option, set user pass file, and then we specify the path to the word list. So it was user share word lists, then Metasploit, I believe, and then mirai user, and then another underscore, and then pass. So we set the path to our brute force list, or basically password and username list. And now if we clear and show options once again, I believe now we should really be good to go. So let us run this. We press here run, and it should start brute forcing the SSH on port 22. As we can see, it is starting different types of the usernames and passwords, and it is going by that list that we specified. So these are all failed ones, and if it reaches one that actually exists, it will stop and it will prompt us with a success. So here we can see root, admin, and root, and some of the other passwords. Now I'm not really sure how many passwords are in this list, so we will not be waiting for this to finish. I just wanted to show you some of the different types of SSH auxiliary modules that you can use. So we saw how we can actually scan the version of SSH, and we also saw how we can brute force the SSH. Now you can actually try this both on Metasploitable and on the OWASP virtual machine. I'm not really sure if this password list has username and password for those machines, but it doesn't really matter, since the process of attacking is the most important. So now you can use any password list you want and actually hope that you will brute force the SSH. So that would be it about this tutorial. In the next tutorial we will cover another auxiliary module that we will use to attack another service running on our OWASP virtual machine. So that would be it for this tutorial, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and now let us perform another scan or another attack on our OWASP virtual machine. So start off your Metasploit Framework console. We'll perform once again the nmap on this framework on this OWASP virtual machine in order to see the available services running. So then we will choose which one we will attack. Now in this, basically I already chose, so we will attack the Tomcat server, but let us first run the attack itself. So 192.168.1.2, and this should finish in a few seconds, and we will attack the Tomcat running on port 8080. Now there is an auxiliary module that is in this Metasploit framework that can be used to attack it. So let's let this finish. So here it is. And we can see on port 8080 over TCP there is Apache Tomcat running. So what we will basically do is we will actually brute force the the Tomcat server. So let us actually search for the Tomcat and see what kind of available exploits and auxiliary modules we have. So right now we are only interested in the auxiliary part. So what we want to use is, let me just find it, I believe it is this one. So it is auxiliary scanner HTTP and then Tomcat mgr login, Tomcat application manager login utility. So I believe it is this one. As we can see, this one doesn't have the date of when it came into the Metasploit as well. It is ranked as normal, so let us use that one. So we use, now if you do not want to copy the module, you can just type it, so auxiliary and then tab to complete, scan and then tab to complete, HTTP and then Tomcat mgr login. So once you click enter on that one, you can just check it with show options, so we can see what are the available options that we have here. Now this one has even more options than the previous two attacks or two scans that we did in the previous video. So let us see what we can do with this. Blank password selected as no. Brute force speed, now brute force speed we will leave on 5, or let's actually try to enlarge it to see if it can actually go faster. So set brute force speed and let's set it on, for example, I don't know, 8 maybe. Oh, whoops, it is actually from 0 to 5, I just noticed, so we cannot set that to 8. But we can try to set threads to more, so it actually goes faster. So we will set brute force back to 5, since 5 is the maximum that it can go. The other options, db all creds, db all pass, db all users are not required and we will not put them. Password we do not need, since we want to specify the password file list and the username file list. As we can see, by default, this actually auxiliary module has pass file already listed, so it is on user share Metasploit Framework, data, word lists, and then Tomcat mgr default pass.txt. So this is file containing passwords, one per line. It is not like in the previous video that we had in the same list, we had usernames and passwords. Here we have it split in a password list and in a user list. So we will stick with this one since it is by default. I guess it has some good Tomcat default passwords and users. Proxies we do not need. What we do need and what we will always need is the rhosts. So we need to select the rhosts, which is our target's IP address. So it is 192.168.1.2. Press enter. So that we selected the R port is 8080 unless it is running on some other port. Now, since we did the nmap scan on our OS virtual machine, we know that it indeed is the port 8080. So we will leave it on that. It is also a required thing, so these two things will always be required. You cannot perform scan without this. So that's important to know. The next thing, SSL is not required. Stop on success. Now, stop on success we want to set to true, since we do not need to continue brute forcing it after we find the username and password. So let us change that. So set stop on success from false to true. And it is set as well. The next thing, target URY is manager/HTML, which is good. So this is a good path, I believe. Let me just check. So if we go to the Firefox, this is basically the path to the login page of the Tomcat server. We go right here and we go 192.168.1.2 slash, and then, or not slash, we need to specify the port, since the Tomcat is running on port 8080, and then we go manager and then HTML. Let's see. Yeah, of course, it does prompt us with the username and password. So basically what we are brute forcing is this right here. Once we find the username and password for this, we will be able to change the settings on Tomcat server, web server. So let us close this for now. You can see we got the error 401 unauthorized since we didn't specify the username and password, but that is soon about to change, hopefully, if we find the correct username and correct password. So did we set the the stop on success true. We did. The next thing that we need is the verbose, which is set to true. That is good. The user file we also have, it is containing users, as it says file contains one per line. So let us check, let us first clear this, and then type show options once again, in order to double check that we successfully set everything as we need. So everything is set, and now what we want to do is click here, run or exploit. So you can use both of those words and just press here enter. We can see it goes relatively fast. It actually went faster than I thought. So let me see, did we even select the number of threads to be larger? We didn't even select that, so let's actually try. First of all, we did find the username and password. As we can see, a plus sign right here says login successful, root and OSBWA. The root is the username and the password is the OSBWA, which we will soon check, but let me just try to run this. It went too fast. So set threads 5, for example, and let's actually try to exploit it once again. Well, it goes the same speed, okay, doesn't really matter. What matters is that we successfully brute force the Tomcat, and now let's actually use this username and this password to log in to the web server. So we reload this page, it will ask us for username, which is root, and the password, which is OSBWA. We press here OK, and we can see that we successfully logged in into Tomcat Web Application Manager, where we can now change all of these settings if we want to, and this shouldn't be available to us at all as a user of the website. So that would be about it for this attack. We covered the, whoops, I went to the, it doesn't matter, let's just close this. We covered the Tomcat auxiliary module, so scanner/http/tomcat-mgr.login, which we use to brute force the Tomcat on port 8080, and we successfully did it. So that would be it for this tutorial. In the next tutorials we will start off with some of the exploit modules, and we will try to exploit some of the more advanced things such as PHP injection, command injection. We want to get the Meterpreter shell back. We will also at the end start exploiting the Windows host machine. So that would be about it for this tutorial, and I hope I see you in the next one. Bye.